Assalamualaikum and hi, my name is Mohamed Syahir bin Saharudin. So today I will present about road segmentation system for autonomous vehicle. This project was supervised under Dr. Abu Ubaidah bin Shamsudin. Okay, for project background, as we know, autonomous vehicle is a vehicle that able to sensing the surrounding and also able to operate without human involvement. Autonomous vehicle also come with an AI system which it can decide by its own. And autonomous vehicle also come with the road segmentation for safety. Okay, this is the problem statement that I found during my research. As we know, road accident cause of fatal injury and death. 20% of the total death in Malaysia are contributed by road accident. And according to JKR report, 60.6% road accident are caused by the driver, and following 13.2 caused by the road condition, and 6.2 vehicle condition. Okay, the latest cases during road accident is during the MCO period, which is involve a policeman, and it cost his life at the scenes. Okay, objective for this project, I will highlight three objectives here. So the first one is to develop a data set to use for your lab system using a labeling application. Secondly, to construct algorithm to be used in your lab. And lastly, will to evaluate the accuracy of your lab in different situations. Okay, scope of the project. Applying the algorithm developed into the your lab application, and then the appearance of the line on road around the Faculty of Electrical and Electronic Engineering (FKE). So this is a project overview. So the camera will act as an input. It will record all the road, all the view, and then the object detection your lag will be processed inside the NVIDIA Jetson, and the output, as you can see, here is the output, and the vehicle also will stay on the right lane. For literature review, okay, I have highlighted several methods that I found during my research. The first one is CNN. Some of the reference state that CNN is much more robust, and accuracy can be increased by the deep CNN. Okay, specific operation result define the features in map. Okay, the result will obtain will have a third dimension. Adaptive and learning various pattern and texture to detect the object. The number 5 reference said the deep CNN have branch of convolutional layer. The lower one will be used to extract local features of image, while the higher layer has abstract global information. Okay, second method is combined method. Reference number 3 propose a combination method which combine the half line transformation and line selection. Okay, according to the reference number 3, the block diagram. Okay. Block diagram below show the purpose method for area for road detection process involved in method as follow. Acquisition of input in RGB format, extraction of rational invariant for uniform local binary pattern. As you can see, it's an input, road detection area, input, K-mean clustering, A and N selection of K-means, HLT and line selection, and then for obstacle detection, it will use gray scale segmentation, vertical projection, and considering of the output is consideration of vertical projected signal. Okay, the third method I found is fast RCNN. According to the number 6 reference, a fast RCNN is unified, deep learning based and end-to-end object detection framework, and it also running in real-time frame rate. Okay, the extractor are used in the first stage for pre-processed input image. in here. The second stage for fast RCNN detector, each proposal object region of interest pooling layer will be extracted to fixed length feature vector from feature map, and the output here is will be fully connected layer is related to the class label and refine the bounding box by each feature vector. Okay, the fourth one is a retina net. Retina net use feature pyramid network. It extract multiple scale information and perform classification, and box regression is on stage. Okay, extreme imbalance class background and address class foreground is a novel loss function in RetinaNet. With this function, RetinaNet can detect object with high accuracy with and fast interference time. Okay, common object, context object COCO show RetinaNet with residual assemble transformation could achieve better for deep neural network. Okay, the fifth one is a stereo camera. Autonomous vehicle must be aware of precise information either in front or in back, and also move left and right if necessary by using lane information. Reference number 12 introduced a method with separating the road from vehicle using stereo camera and lane recognition using the dynamic programming on separated road and Kalman filter. Okay, for this project, based on the all the method found, for this project I will use YOLAC. YOLAC is a fully convolutional model for real-time instance segmentation. YOLAC can be divided into two parts, which is set is generating of prototype masking and predicting per instant mask coefficient. Okay, the advantage of YOLAC is firstly it's a parallel structure, as you can see in here. Okay, and it also extremely lightweight assembly process. So each branch have its own task, and the last one it will combine the both output from each branch into the output here. Methodology of project. So this one is a flowchart and block diagram. As you can see here is a flowchart of the project. Okay, starting from the data set until the training YOLAC, it come in the one part which is a YOLAC training part, and from the camera running YOLAC for real-time detection until the process with root, this one is come in the decision making part. Okay, for block diagram, as you can see, we are using the camera module to record and collect all the information, and then the information will be processed inside the NVIDIA Jetson Nano using YOLAC, and the output it will highlight the road that we want. Okay, for the hardware, we are using the NVIDIA Jetson Nano because it has a GPU, and GPU is really important for image segmentation. Okay, as you can see here, this is a specification of NVIDIA Jetson Nano. Okay, the second one is a camera module. This one is a HD camera module, which is it can record the video in 1080p for 60 frames per second. Okay, and it has premium full HD glass lens, which is it can record with the full HD video resolution. And second one is we are using a dash cam. Dash cam is just in HD. It can record in 1080p HD only, and its angle is 160, and it has a G sensor, voice control, and 3D noise reduction. Okay, for the software, we're using three types of software here. So YOLAC is for the road segmentation. We're using it for instance segmentation. Okay, for Python, we're using it to write the programming for the YOLAC. Okay, and then the lastly is for ROS for simulation that we will run after complete the programming. Okay, for result, as you can see here, there's 7 places that I'm going to be used to for the first objective, which creating a data set for the system. On the left column is the picture of a places during morning and noon, and the right column is for night. Okay, the second one is a masking process using labeling application. The left one is the image before labeling process, and the right one is during the labeling process. Okay, for the first one, I'm masking the road in a red color, and the second one is I'm masking the area which I'm not considering is it as a road in a green color, so the output should be a green and red color. So the green one is for no road and the red one is for a road. Okay, this is the result of the image. So I'm masking all the image that I take with my camera, and I'm masking it to determine which one is the road and which one is not road. So as conclusion, in PSM1 I managed to achieve the first objective, which is to develop the data set to be used with your lab. Okay. For the future work for this project, in order to achieve the second and third objective, I will develop an algorithm that can be used with your lab application. And the last one is a data set that I'm working in PSM1 will be keep updated in order to be used and to evaluate with to the accuracy of your lab in the different time, situation and condition of light visibility in the area for this project. Okay, that's all. Thank you.